Hi everyone, in Algebra 3, today we're going to be going over the new material for lesson 70. And in this lesson, you're actually probably going to need to either use your book on page 442 or have your answer key out, because we're going to be going over one of the tables that are located within either your book or in your answer key. So lesson 70 is going to be going over percentiles and something called the z-score. And what the z-score is also known as a standard score, because it's going to tell us how many standard deviations one value is away from the mean in either direction of the mean. So it could either be under the mean or it could be over the mean. And then from the standard normal table, from the z-score, we can actually find the percentile that value falls within. So what we're going to do is I want you guys to open your books, and we're going to look at 70.1. It says the mean weight of the babies born in a metropolitan hospital for 7 years was 6.8 pounds with a standard deviation of 0.8. If the distribution of the weights were approximately normal, what percentage of the baby's weight weighed less than 6.4 pounds? Okay. So what we're going to do is we're going to use this equation, which is the z-score equation. And the x is going to be the value that we're actually evaluating. This is going to be the mean, and that's the standard deviation. So the z-score would be x minus the mean divided by the standard deviation. And once you get the z-score, that's when you're going to use our chart. So the x that they give us is the baby's less than 6.4 pounds. So that would be 6.4 minus the mean, which is 6.8, divided by the standard deviation, which is 0.8. So you can use your calculators to evaluate that. So 6.4 minus 6.8 and then divided by 0.8 would give us negative 0.5. So now what you're going to do is you're going to take out your chart, and this is located in the back of your answer key. And now what you're going to do is you're going to go to negative 0, because it's negative 0.5, and then over the chart to 0.5, so negative 0.5 would give us a percentage of 30.85%. So there's a decimal number there, but really we're looking for the percent. So you multiply that by 100. So down to negative 0 over to 0.5 gives us a percentage of 30.85%. And those percentages in the standard normal table are actually all the percentages that fall below that value. So if you wanted to find the percentage above, you would actually have to subtract it from 100. So again, all of the standard normal table percentages, all of these percentages are what falls below that value. So if you wanted to find the values that go above, you would have to subtract it from 100. Okay, so now we're just going to move on to looking at your lesson. So number 7. So I want you to attempt this problem before you actually follow it along. But it says the scores of a test are normally distributed with a mean of 75 and a standard deviation of 8. What percent of the test scores are less than? So less than means that's going to follow the standard normal table, less than 87. So I need to calculate the z-score first, and it's always going to be x minus the mean divided by the standard deviation. So the x is going to be the 87. The mean is 75, and the standard deviation is 8. So that would give me 87 minus 75 divided by 8, which gives us positive 1.5. So now I'm going to take out my standard normal table. I'm going to go down to positive 1 and then over to 0.5. And that gives me a percentage of 93.32%. So our answer is 93.32%. So you use the z-score to then calculate or to find the percentage that falls below that value. Okay, and that's number 7. Now we're going to start on number 10, and we're going to kind of work our way through a little bit of this lesson together. So for number 10, it says a parabola has a vertex at 2, -1, and its focus at 2, 4. So now what I'm going to do is I'm going to actually draw this. So 1, 2, 3, 4. So the vertex is at 2, -1. This is my vertex. My focus is at 2, 4, which is about here. Remember that your parabola always opens up towards the focus, so you can just input your parabola there. The directrix is going to be the same distance away from the vertex to the focus as the vertex to the directrix. So if I count, that would be 1, 2, 3, 4, 5 spaces. So away in the other direction would be 1, 2, 3, 4, 5. And that would put my directrix here. So the equation of that line is going to be y is equal to, it's crossing the y-axis at 1, 2, 3, 4, 5, 6. At -6. My axis of symmetry is going to be on the x-axis. Where do all these points line up? And that would be at x is equal to 2. Now we need to find the equation of the parabola, and that is going to be in the form y equals 4p times x minus h squared plus k. So now I need to find what my variables are. So my vertex is at 2, -1. And those variables for the vertex are always h, k, which means that my h is going to be equal to 2 and my k is going to be equal to -1. Now for my focus is at 2, 4. And the variables for that are always h, k plus p, which means that the h is equal to 2 and the k plus p is going to be equal to 4. K plus p is going to be equal to 4. Now the k is equal to -1, which means that the p is going to be equal to 5. And these are going to be your 3 variables that you plug in. So now I plug that in, I get y is equal to 1/4 times 5 times x minus 2 plus -1. And that should be squared. So my answer is going to be y equals 1/20 times x minus 2 squared minus 1. And that's your equation of your parabola. And then your directrix, equation of your directrix, and the equation of the axis of symmetry. And those are all your answers that you need, as well as the diagram that we have here. Now moving on to number 11, we are asked to sketch this. And what I'm going to do is I'm going to actually convert this from logarithmic form into exponential form. So 9 is my base, n is my, x is my number, and this would be my exponent. So when I rewrite this, it would be x is equal to my base 9 to the power of y. Now what I'm going to do is I'm going to make an x and a y chart, but instead of plugging in for x, I'm going to plug in for y. So I'm going to plug in -1, 0, and 1. When I plug in 9 to the -1, it's going to flip it and make it 1/9. When I plug in 9 to the 0, it would be equal to 1, and 9 to the 1 would be equal to 9. So now this diagram is going to be flipped on its side. It's going to be an interesting diagram. So it'd be over 1/9 down 1, over 1 up 0, and then over 9 up 1. So your thing should look something like this. And that's going to be my sketch of my function. So it is an exponential function, just flipped on its side. Okay, for number 12, we're going to be graphing, we have the equation 3x squared minus 12x plus 3y squared plus 18y minus 24, and we're trying to graph this. So the first thing that I'm going to do is I'm actually going to divide off whatever I can. So I actually can divide this whole equation by 3, which would make the equation x squared minus 4x plus y squared plus 6y equals, and then when I divide this by 3, that would be 8, negative 8. But when I move it to the other side, it becomes positive 8. Now I'm going to complete the square. So half of negative 4 would be negative 2. I square that would be positive 4. Whatever I do to one side, I have to do to the other, so I'm adding 4. Half of 6 would be 3, so that would be y plus 3. I square that and I get 9. Again, whatever I do to the left, I do to the right, so I have to add 9 to the right. So on the right, I have 8 plus 4 plus 9, which gives me 21. Unfortunately, that does not come out evenly. So my diagram for the center of the circle is going to be opposite of what's given. So it's negative 2, so that would be positive 2. Opposite of 3 is negative 3. That's the coordinate for the center of the circle. And my radius is always the square root of the right-hand side, which in this case would be the square root of 21, which is approximately equal to 4.6. So, yikes. Now I need to graph this. So I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is about what it's going to be. So 2 down 3 would be the center of my circle, and the radius is approximately 4.5. So 1, 2, 3, 4 and a half. Then 1, 2, 3, 4 and a half. Then 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. And this is going to be my circle. And the radius is going to be the square root of 21. Now we're going to look at numbers 13 and 14, which we're going to need the book for. So for number 13, we have that we need to write the equation as a sine function, and the second one we're going to write as a cosine function. And I'm going to make this into a positive sine function. So I'm going to make this into y is equal to a plus b sine c x minus d. A is going to be the midpoint between the top and the bottom variable. So if you look closely, the top and the bottom are 22 and then negative 40. So I need to find the midpoint between 22 and negative 40. So you're going to add them together, then divide by 2. Then B is going to be the top number, which in this case is 22, minus whatever I get for A. Okay, so now looking back at my work, I have 22 minus 40 divided by 2 would give me negative 9. Then I have 22 minus negative 9. So 22 plus 9 gives us 31. Now for C, it's going to be 360 divided by the length of the period. I think this is where a lot of people are getting confused. So for the length of the period, notice that it's starting at negative 130. It circles up and then circles up and to 110. So the length of the period would be the distance from negative 130 to 110. So when you're calculating the length of the period, it would be 360 divided by 130 plus 110, like that. So if I do 130 plus 110, I'm going to get 240. So that would be 360 divided by 240. Those are both divisible by 6. So that would be 6 over 4. So 3 over 2. And then we have to look at the phase shift. So for the phase shift, notice that it's currently crossing at -10, but we want it to cross at 0. So I would need to shift this over 10 degrees to the right in order for it to pass through the origin. So for this one, our result is going to be as follows. Y is equal to A, which is -9, plus B, which is equal to 31, sine C, which is 3 over 2. And then this needs to be shifted over to the right 10 degrees, so plus 10 in the positive direction. Now for my next one, for number 14, it's going to be similar to the last one, but we need to put this in terms of a cosine function. And I'm going to make it into a positive cosine function. So that would be y equals a plus b cosine c of theta minus d. Now again, my a is just going to be the top plus the bottom divided by 2. So it's just the midpoint between the top and the bottom value. So for a, that would be top, which is 14, plus bottom, which is positive 10. And then you're going to divide that by 2. And then b is always the top minus whatever you got for the for a. So in this case, we have 14 plus 10 would be 24 divided by 2 would be 12. So this would be 14 minus 12, which is 2. Now c, this is going to be 2 pi divided by the length of the period. So I'm going to show you how we calculate the length of the period. So what I'm going to do here is I see that it peaks down at -pi and then peaks down again at 2 pi. So that means I need to know the distance from -pi to 2 pi. So when I calculate that, it's going to be 2 pi divided by pi, where it starts, plus 2 pi, where it ends. So it would be 2 pi over 3 pi, which simplifies to 2/3. Now is the phase shift. So currently it's peaking at pi over 2. I need it to peak at 0. So I need this whole graph to shift to the left in the negative direction, pi over 2. I'm going to shift it all to the left, pi over 2, which is now how we get our answer. Our result is going to be y is equal to 12 plus 2 cosine 2/3. And that would be theta minus pi over 2. Again, you're shifting it over pi over 2 radians. And that's your result for number 14. Now moving on to number 15. So for number 15, what we're going to do is we need to solve for x, which means that we need to eliminate y. So I'm going to multiply the top equation by -j, the bottom equation by w. So if I multiply the top equation by -j, I get -djx plus jwy equals -js. And that's going to be over, I multiply the bottom by w, so that would be kwx minus jwy equals aw. So our jwy's are going to cancel, and you're going to be left with kwx minus djx equals aw minus jc. Factor out the x, so that would be kw minus dj equals aw minus jc. So therefore, x is going to be equal to aw minus jc over kw minus dj. Now moving ahead to number 16. So for number 16, you are going to start by multiplying the outside numbers and then adding the degrees together. So that would be 5 times -3 would give me -15. And when I add -312 plus 72, I get -240. And you do need to expand that. So that would be -15 times cosine of -240 plus I sine of -240. -240 is going to be in quadrant 2 with a 60-degree angle. So adjacent would be -1, opposite √3, hypotenuse 2. So cosine would be adjacent over hypotenuse, so that would be -15 times -1/2, because adjacent over hypotenuse plus opposite over hypotenuse would be √3 over 2i, and we're going to distribute that -15. So that would be positive 15 over 2 minus 15 √3 over 2, and don't forget your I. Okay, so you have to multiply and then also expand that one as well. Now moving on to number 17. So for number 17, we have to do the same thing, but this one's going to be in radians instead of in degrees. So it works the same way. You're going to do 6 times 2, which is the outside two numbers, and that would give you 12. And then you're going to add the 2 radians. So 4 pi over 3 plus pi over 3 would be 5 pi over 3. You're going to expand this. So that would be 12 times cosine of 5 pi over 3 plus I sine of 5 pi over 3. And we're going to use our snowflake chart here. So with 3, that would be 1, 2, 3, 1, 2, 3. Starting at 0, we're going to count 1, 2, 3, 4, 5. That puts me in quadrant 4. And anytime the denominator is 3, that's a 60-degree angle. So that would be positive 1 to the right, down -√3, and then the hypotenuse is 2. So the cosine of this triangle would be adjacent over hypotenuse, which would be 1/2, plus opposite over hypotenuse, which would be -√3 over 2, but don't forget your I. So now when I distribute the 12, I'm going to get 6 minus 6√3, and then my I. And that's number 17. Then looking at number 18. So for number 18, this is already factored for us. So we actually need to just set these two equations equal to 0 to solve. So I'm going to have √2 sine x minus 1 equals 0. And then I have √3 minus 2 cosine x equals 0. So now I'm going to move the 1 to the other side. So add 1. So that would be sine x equals 1 over √2. This one, when I move the √3 to the other side, I get -√3, but then I'm going to divide by -2. So really that turns into positive √3 over 2. So now I need to find where is sine positive. So if I use all students take calculus, I know that it's positive in quadrants 1 and 2. The opposite 1, or hypotenuse √2, opposite 1, hypotenuse √2. This is actually going to be a 45, 45, 90 triangle. So I actually need to find out what that is in radians. Then for my next one, I need to find out where cosine is positive. Well, everything is positive in quadrant 1, and cosine is positive in quadrant 4 because of that C. So that would be 2 triangles in quadrants 1 and 4. So that would be root 3 over 2. And that's going to be a 30-degree angle in quadrants 1 and 4. So now I'm going to use my chart over here. I know that whenever it's a 45-degree triangle, there's going to be 4 arrows, meaning the denominator will be 4. And starting counting in quadrant 1. So for the first one, this is just going to be the triangle in quadrant 1, which would be pi over 4. For the second one in quadrant 2, I would count 1, 2, and this would actually be 3. So that would be 3 pi over 4. So it's basically going backwards from what we were doing before. Now for my chart for a 30-degree angle, it's actually going to have a denominator of 6. This one's a little trickier because there's more than one line in each quadrant, but it's always going to be the line closest to the x-axis when you're counting for 30. It's going to be your 0. The first one is quadrant 1, so that's going to be just pi over 6. The second one is in quadrant 4, so I have to count all the way around. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this would be 11, line number 11, and 11 pi over 6. Okay, and that concludes that problem. Now we're going to do number 19 as well. This one's also going to have the parameters of between 0 and 2 pi. So we have to also convert this to radians. Now this one's a little tricky. So before I can actually factor this one, I'm going to set x equal to cosine x. So I'm going to just change all my cosine x's to x's. So that would be 2x squared plus x minus 1 is equal to 0. Now I have to solve for x so that I know what to set my cosine x equal to. So I'm going to do quadratic formula. So x is going to be equal to -1 plus or minus the square root of 1 squared minus 4 times 2 times -1 all over 2 times a, which is 2. So I'm going to get -1/4 plus or minus the square root of 1 plus 8 over 4. And you should know that the square root of 9 would also be equal to 3. So that would be 3 over 4. So now I have two results. I have x is equal to -1 plus 3 would be 2 over 4, and that would be 1/2. And then I would have x is equal to -1 minus 3, which would be -4 over 4, and that would be -1. But remember in the beginning how I set my x equal to cosine x. So I'm actually going to change this now to cosine x is equal to 1/2, and then cosine x is equal to -1. Now, where is cosine positive? Well, if I make my chart, I have all students take calculus. Cosine is positive in quadrant 1 and then also in quadrant 4. The adjacent is 1, the hypotenuse is 2. So this is actually going to be a 60-degree triangle. This would be root 3 and -√3. This one right here, -1, I actually need to use my unit circle. So I'm going to draw that. Be 1, 0, 0, 1, -1, 0, and then 0, -1. And cosine is equal to the x coordinate on that chart. So on this chart, if I underline all of my x coordinates, the only x coordinate that's equal to -1 is this one right here. That's equal to 180 degrees. Now 180 degrees is actually equal to pi radians, which means that my answer is just going to be pi. because 180 degrees is equal to pi radians. Now for this one, I have to draw my snowflake chart, and I'm going to have my 60-degree angles marked. So there should be 3 between 0 and 180 and 6 total. So when I count, my first one is going to be in quadrant 1, so that's just going to be pi over 3. My second one's in quadrant 4, so I have to count all the way around the circle. So that'll be 1, 2, 3, 4, and then this would be 5. So that'd be 5 pi over 3. And that would be your result for number 19. So making sure that you convert those into radians, not put your answer in degrees. Now the last problem that we're going to do is going to be number 20. So the first thing that we have to do is we need to evaluate the tangent of negative 210. So I have arc tangent of negative 210. And negative 210 would put us in quadrant 2 with a 30-degree angle. So this would be negative root 3, 1, and 2. The tangent is opposite over adjacent. So this is going to be arc tangent of negative 1 over the square root of 3. And I need to find out the first place where tangent is negative. So if I look at my chart, all students take calculus. I'm not using quadrant 3. I'm not going to use quadrant 1. But I know that tangent is negative in quadrant 4, so I need to draw a triangle in quadrant 4. I'm going to label the sides opposite negative 1 adjacent root 3. My hypotenuse is 2. Now this is a 30-degree angle in quadrant 4, which means that my x, or theta, is going to be either equal to negative 30 degrees, or you could do positive 330 degrees. And that is your final result. And that concludes what we're going to do on lesson 70. I hope you guys all have a great day. Remember to get your stamp in for lesson 69. Bye.